Alright, let's describe the transformations that must be applied to y is equal to x squared to obtain the function f of x is equal to negative x plus 3 squared minus 5. Okay, so we want to start with our function y is equal to x squared. This is a parent function and it's a quadratic function, right? And we want to look at its transform function. Y is equal to a, b, let's use k here, k x minus d squared plus c. Okay, so this time we're just looking at the function, and we're basically going from x squared into this guy. Okay, so by looking at that, you can notice here that f of x is equal to negative x plus 3 squared minus 5. A here is equal to negative 1. Okay, b here is 1, so we don't have to worry about b. The d value here is actually negative 3. Okay, because the negative 3 would make it positive 3, right? You don't need to put brackets around it. Okay, so it should be negative 3. And the c value, the vertical shift here, is going to be negative 5. Okay, so we're going to look at all of our transformations. So the first transformation, you can see if a is less than 0, we have a vertical reflection. And a vertical reflection is basically a reflection in the x-axis or over the x-axis. Okay, and in this case, what we mean by vertical reflection is y is equal to negative x squared. Okay, so what does that have to do with the function? So how does that affect the function, right? Now we have this question that's telling us to graph the function. Instead of graphing the function, guys, what I'm gonna do here is I'm going to show you this using a table of values, because when you graph multiple transformations, it makes it really messy. I'm gonna start with x and y is equal to x squared. I'm gonna take these points, so negative 2, negative 1, 0, 1, and 2, and these are the equivalent y values. Okay, and a vertical reflection, what's going to happen here is that all of the y values will become negatives. Your x values won't change. So vertical transformations will not change the x values, right? So in this case, I'm going to copy down my x values from the previous transformation, from my previous parent function, and now we're going to have basically negative y, or basically y is equal to negative x squared. Okay, so you're going to see negative 4, negative 1, right? 0, negative 1, and negative 4. Okay, so that's what happens to our points when we apply this transformation. Now, in our second scenario, okay, we have a shift. Okay, so we have a horizontal shift 3 units left. Okay, so if we have a horizontal shift 3 units left, look what happens to our point. So because it's a horizontal shift, we're only going to be affecting our x values and not our y values. So I'm going to copy down the y values from the previous step. You can notice here that the function now will look like this. Y is equal to negative x plus 3 squared. Okay, and what we're going to do here is we're going to subtract 3 to all of our x values. So we're going to get negative 2 minus 3, which is negative 5, negative 1 minus 3, which is negative 4, 0 minus 3, which is negative 3, 1 minus 3 is negative 2, and 2 minus 3 is negative 1. Okay, so these are our points. In the last case, we have a third transformation. We have a vertical shift 5 units down. Okay, so if we have a vertical shift 5 units down, what that's going to do to our function, now we're going to have y is equal to negative x plus 3 squared minus 5. And if you address the points here, whoops, let me just make some space here. Okay, so if we address the points, right, because we have a vertical shift, you can copy down your x values. It should basically be the same x values as the previous transformation. So negative 2, negative 1, for y values, what I'm going to do here is I'm going to subtract 5 from each of these y values. So negative 4 minus 5 is negative 9, negative 1 minus 5 is negative 6, 0 minus 5 is negative 5, negative 1 minus 5 is negative 6, and negative 4 minus 5 is negative 9. Okay, so this is what your final points will look like. Okay, so we can actually graph all of these points and create our graphs. For each transformation, I just thought we would look at it using a table of values because it's a lot more organized and more effective in observing what happens to these transform points.